Hello, good to see you again. Welcome to Block 5, Fraction, Decimal, and Percentage Equivalence, Lesson 9. I'll share my screen. So, in your previous lesson, you learned how to convert fluently between simple fractions, decimals, and percentages. In today's lesson, you're going to learn how to use and interpret pie charts. I want you to pay really close attention at what we'll be doing in today's lesson because the skill is going to become really useful in future lessons when you start to draw pie charts. But before we start, I want to ask you to support our global educational program to provide free maths education to children around the world, regardless of whether they can afford a private teacher or not. So, to do that, it's a huge favor you're doing to us and to others. Share the videos, like the videos, and subscribe to the channel to encourage our continuous growth. Thank you. Before we start, I would like you to answer these retrieval practice questions. So, retrieval practice to help you think about what you learned in your previous lessons. I would like you to pause the video and answer these questions in 3 minutes. You can take longer, you can take a shorter time frame. It is up to you. Assuming you've paused the video and you've worked through these questions, let's look at the answers. So for the first one, you were asked what fraction of the circle is shaded. You can see that the circle is divided into 5 equal parts. And out of those 5 equal parts, 3 parts are shaded. So we'll say 3/5. So 3 out of 5 parts. So 3/5 means 3 out of 5 equal parts. Next one, we're asked what percentage of the rectangle is shaded. Here we can see that the rectangle is divided into 4 equal parts and 3 parts are shaded. If you recall in our previous lesson, we learnt about what quarters does to 100 squares. So quarters would split 100 squares into 4 equal parts. Each part represents 25%. So if we have 3 parts, then it means that it's 3 times 25. So 3 quarters is 75%. Okay. Next one, we're asked, is the statement true or false? Of course, the statement is false. Why? They are not divided into equal parts. So we cannot say that the shaded part represents 1/3. Okay. Let's move on. Let's do some new learning. Here we have this circle. How many parts is it divided into? Look at the dots and see how many parts the dots around the circle splits this circle into. Well, you can see that it divides the circle into 10 equal parts. 3 parts are shaded, so we'll say 3/10 is shaded. 3/10 is shaded. And remember, 3/10 is the same thing as 30%. If you do not know what I'm talking about, you can go and view our lessons, our previous lessons, where we have done a lot of learning about how to convert between simple fractions, decimals, and percentages. Here you can see that the circle is divided into equal parts, but this time there are different number of equal parts. There are 5 equal parts. Three parts are shaded, so we'll say 3/5 is shaded. Okay. So what's different is that here we divided the circle into 10 equal parts, but here we divided the circle into 5 equal parts. So 3/5 is shaded. Now, did you remember what fifths did to our 100 squares? Well, fifths divided our 100 squares into 5 equal parts. Each part was equal to 20. So 20 squares, which represented 20%, made up a fifth. So 20% is the same thing as a fifth, 1/5. So if we have 3/5, it means 3/5 is equal to 3 lots of 20%, which is 60%. What about this one? If I ask you what proportion of the students liked Jews, would you be able to answer it? Well, you may be thinking, this is similar to the last question we had in our retrieval practice question. They are not divided into equal parts. So it is not really easy, or it's not accessible to quickly say the fraction or proportion of the students that liked Jews. But what if we put dots around the circle so that we split the circle into equal parts? Well, you can now say, oh, I know. The part representing Jews is split into 3 equal parts, and the circle is split into 10 equal parts. So the proportion of students who drank juice is 3/10. Okay. What was the most popular drink at lunchtime? I'm sure you would say water, because we have a higher number of parts compared to the other parts. All right, so what we've learned so far is we have learned how to represent proportion as parts of a circle, which will give us the proportion of a pie chart. So pie chart means you're taking a circle which represents the data, and then you're splitting the circle, telling the proportion which represents different components of the data. I would now like you to pause the video for 2 minutes and answer question 1. Assuming you've paused the video and you've worked through the questions diligently, here are the answers. You can mark your work and celebrate your success. For question 1, you were asked, what fraction and percentage of each pie chart is shaded? Here we can see that the circle is divided into 10 equal parts and 7 parts are shaded. 7/10 represents 70%. Here we can see for B that the circle is divided into 4 equal parts. 1 part is shaded, and you know by now that a quarter represents 25%. Here, the circle is divided into 5 equal parts. 3 parts are shaded, and you can see that 3/5 is the same thing as 60%. Pause the video and answer question 2 in 2 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. You can mark your work and celebrate your success. For question 2, you were asked, what fraction of the families took a holiday in the UK? Well, you can see that the circle you've been given, the dots are placed on the circle to help you split the circle into equal parts. So you can see that that represents 3 parts, so it is 3/10, which represents 60%. Next, you ask, What proportion of families went to somewhere other than the UK? Now, if you look at this carefully, other than the UK, and then you're asked to give your um, answer as a decimal. Now, if you think about it, other than the UK, we have, so other than the UK is this portion here. Now, you can see that this represents 60%, this represents 30%, and this represents 60%. So other than the UK is 10%, which is 10 out of 100. And by now, you know that 10 tenths, this represents 1/10, which is, if you think about our previous lesson, this is 0.1. Okay? All right. Let's rub this off. Let's carry on. Let's plane up a bit. Okay. All right. Pause the video and answer question 3 in 2 minutes. Assuming you've paused the video and you've answered question 3, here are the answers. Let's discuss them. Here you asked what percentage of students travel to school by car. Well, you can see that the pie chart helps us split the circle into 5 equal parts. And then 1/5 represents 20%, because traveling by car, you can see that that represents 1/5 of the circle. My pen is playing up. Okay. All right. And then next you ask what proportion of children walk to school. You can see this represents 1, 2, so 1, 2, 3. So 3 parts, 1, 2, 3. So the dots around the circle splits this part into 3 equal parts. So that is 3/5, which is 60%, and is the same thing as 0.6. Pause the video and answer question 4 in 2 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. Let's discuss them. Here you're told the pie chart shows the amount of waste recycled by a school. You asked, how does the pie chart show that the school recycled more than they did not recycle? Here you can see, now note the words that I'm using here, the sector for recycled is larger. So a part, when a circle is split, so take note of this word, it's a very important word. You're going to come across it in your study of maths. So this part here is called a sector. So when a circle is split into parts, a part like this is called a sector. And then what fraction of the waste is recycled by the school? You can see that we have 1 part, 2 parts, 3 parts, 4 parts. So 1, 2, 3, 4, 5. So we have 5/6. So 5 out of 6 parts represents recycling. Well done for doing those practice questions. Let's do some new learning for some further practice on the topic of using and interpreting pie charts. The pie chart shows the favorite primary colors for a group of students. Here you asked, what percentage of students' favorite color is not yellow? Now, take note that not yellow represents red or blue. So we're going to have to find out the parts that represent red together with blue. So red or blue means it could be red, it could be blue. So we have to take account of all of them together. So we have 1, 2, 3, 4. So that is 4 out of 5 parts. Because red is 1/5, blue is 3/5. We put them together, 4/5 represents not yellow. If we convert that to percentage, it is 80%. Why? Remember when we studied 100 squares, right? A fifth splits 100 squares into 5 equal parts. Each part is 20, which represents 20%. So 1/5 is 20%. 4/5 represents 4 lots of 20%, which is 80%. Here, she says 1/5 of the pie chart is red, so one student chose red. Is she correct? Think about it. Well, she's not. We do not know how many students are actually in the group. We do not know. So we cannot say it's one student. Why? Pie charts show us proportion. So proportion means a portion out of the whole. So proportion means you're thinking about a portion out of the whole. So we need more information to be able to work out exactly the number of students. It's now time for you to practice what you've learned. Pause the video and answer question 5 in 2 minutes. Assuming you've paused the video and you've answered question 5, here is the answer. You can mark your work and celebrate your success. So here it says part of the pie chart, the question is, part of this pie chart is shaded blue. You can see it there. What percentage of the pie chart is not blue? Well, again, you need to count the number of parts that represent not blue. You can see the circle is divided into 8 equal parts. And the part that is not blue is 75%. Why? You can see that the circle, it's not responding, just a minute. You can see that the circle is split into 8 parts. So we have not blue is 1, 2, 3, 4, 5, 6. Okay, so as a fraction, that is 6 out of 8. My pen is playing up. All right, so that is 6. Just a minute. Just a minute. Just reset the pen. Okay. Okay, so that is 6 out of 8. And then 6 out of 8, if we simplify that, 6 out of 8 will be 3/4. Okay, 6 out of 8 will be 3/4, which is 75%. Yeah. Then what fraction of the pie chart is green? You can see green is 1, 2, 3. So 3 out of 8. Okay. Next question 6, I will ask you to pause the video and answer question 6 in 2 minutes. Assuming you've paused the video and you've answered question 6, here are the answers. Let's discuss them. Here you ask, the pie chart shows the pets that some students own. Then here you can see the answers. You ask what percentage of students own a goldfish. You can see that the circle is split into 5 equal parts. So 1, 2, 3, 4, and 5. So if you have goldfish is 1/5, which is 20%. And then what percentage own dog? You can see dog is, yeah, you can see that dog is 30%. Why? You can see that it has one part there, which is 20, and then a little bit of that, which is 10. So 20 plus 10. So the way to work it out is here. So 20% own a goldfish. So 50% own a cat. So the remaining 30% is dog. So that's one way to work it out. So you say, well, let's find out these, and then we take it away from 100%. So goldfish plus cat, we take it away from 100%. That gives us the number of the percentage that own dog. Pause the video and answer question 7 in 2 minutes. Assuming you've paused the video and answered question 7, here are the answers. Here you ask some students took part in a survey about their favorite language, and then the pie chart shows the results. You're asked to estimate the percentage of students that chose each language. So you can see Mandarin is 20%, Spanish 30%, and French 10%. So here, all you need to do is to think about how to split the circle into equal parts by visualizing the number of parts you can split them into so that you can estimate it. Now, if you add up the percentage, you will notice that they should add up to 100%. Okay? So that brings us to the end of this lesson. So what have we learned so far? In our lesson, we have learned that with pie charts, you can find out the proportion of pie charts that represent each component in a data by splitting the circle into equal parts, and then you can figure out the proportion by estimating it. Or if the dots are already placed in the circle for you, you can use your knowledge of 100 squares to figure out the proportion of the circle, either as a fraction, as a percentage, or as a decimal. Until next time, take care and bye-bye.